Hey guys, welcome to 7.1. In this video, we're going to be talking about how to write ionic compounds, how to write the formulas for ionic compounds. This is an exciting video because it's the first video of our last unit of the year. Yay for Unit 7. So let's kind of remember some of the things that we did learn before Thanksgiving, fried our brains. One of the things we did learn was the difference between an ionic compound and a covalent compound. So I want to just kind of go over those again. Ionic compounds are compounds that are made of a nonmetal and a metal. And this first video is how to write a formula for an ionic compound. Our second video is how to write a formula for a covalent compound. The rules are different. So when you're given a compound, the first thing you need to ask is it ionic? That's the first question. And so I said the steps to writing ionic formulas, the step right before step number 1 should be, is it ionic? How do we know if a compound is ionic? A compound is ionic if there's a metal combined with a nonmetal. So let's look at our first example. I have lithium and oxygen. Lithium is a metal because it's to the left of the staircase line. Oxygen's a nonmetal because it's to the right of the staircase line. So this is ionic because there's a metal and a nonmetal. So now that I know it's ionic, I will follow these rules right here to write ionic formulas. The first thing I do is I write the symbol for each element. So lithium symbol is this, oxygen symbol is this. Lithium is in group 1, so it has 1 valence electron. Oxygen is in group 16, so it has 6 valence electrons. Something to remember is that when you're drawing the dots, do not pair up your dots on one side until every side has a dot on it. So if you're looking at your oxygen and there's one side of oxygen that doesn't have dots, then you drew it wrong. Make sure every side has a dot before you pair them up. So I know on my oxygen that there's 2 places where I can bond. I can bond here because there's a free electron ready to mingle, and then I can bond here because there's another electron ready to mingle. Lithium has 1 valence electron, so it can only bond once. Oxygen, because it's the nonmetal, will completely steal lithium's electron. But oxygen's not happy. Right now, once it steals lithium's electron, it has 7 electrons. And how many does it want? It wants 8. So oxygen needs to steal another electron. How do I know where it's going to steal it? Well, if only lithium and oxygen are combining, then all I have to do is add another lithium. And if I added another lithium, then oxygen can steal its electron. And now oxygen has 8 and it's happy. And both lithium and the other lithium have 0 valence electrons, which is what they want. Remember, you either want 8 or you want 0. So now that both are 0 and 8, then they're happy. Now I have to think about the charges. Once the charges are evened out, then I know that it's neutral. So here's another way I can write it. Lithium has a +1 charge. Oxygen has a -2 charge. Right now, these charges aren't neutral, but if I added another lithium, that would be adding another +1 charge. Now my charges are +2, -2, and my overall atom is neutral. So now you have to ask yourself, how many lithiums did you use? I used 2 lithiums. And this over here, you can see I have 2 lithiums. So when I'm writing it out, I write it at Li, and then I put a 2 here to indicate I have 2 lithiums. How many oxygens did I use? I used 1 oxygen, as you can see here. So I write O, and I don't put the 1 by it because the 1 is assumed. Okay, so now let's go to move on to another example. This example is calcium and nitrate. Nitrate is not an element on the periodic table. Nitrate is a word that stands for something that we call a polyatomic ion. This next example is asking us to write the formula for calcium and nitrate. Nitrate is a polyatomic ion. It's not an element on the periodic table. We haven't talked about polyatomic ions, so let me just teach you about them here for a second. Polyatomic ion is when I have 2 nonmetals, like nitrogen and oxygen, and I bond them together in such a way that they have an overall charge. Okay? Nitrate, whenever you take 1 nitrogen and 3 oxygens and you bond them together, it's not neutral. It has a -1 charge. Polyatomics, we're going to pretend like they're one unit, and when we move them around, we're going to pretend that they're one thing, and it has a -1 charge. We have a list of polyatomics that you will need to memorize, and they're right here on your reference chart. All of these are polyatomics. These are the names, and then these are the formulas, and notice these are the charges here. The charges are written as plus. Plus means just +1. If you see a dash, that just means -1. If you see a 2 with a dash, that means -2. Here's a 2 dash, and so it means -2. So you can figure out the charge of these ions just by looking at the periodic table. Some of them you have to be careful because the names are similar, like nitrate and nitrite are two different polyatomic ions, but they sound similar because they have names that sound the same. So you have to be careful when you're looking at polyatomics that you're looking at the right one. Okay, so the first thing we do is you write out the symbol. So calcium symbol is Ca. Nitrate symbol is NO3. I also need to write the charges. Calcium's charge is +2. Nitrate's charge is -1, right? Okay. Calcium's charge is +2. Nitrate's charge is -1. If I just have one calcium and one nitrate, I don't equal 0. So which one of these do I need to add another atom or another molecule so that it equals out? I need to add another nitrate. If I add another nitrate, do my charges equal out? My nitrate charges, if I have 2 nitrates, that means it will have a -2 charge. My calcium is a +2 charge, so it's neutral. The goal of every ionic compound is to be neutral. So now I ask myself, how many calciums did I use to make this neutral? I only used 1 calcium, so I don't put a number down, I don't put a subscript at the bottom to indicate 1, because we always assume that it's 1. Now, how many nitrates did I use? Well, when I'm writing nitrate, I have to put the parentheses around it. And then I had 2 nitrates. I had 1 here and 1 here. So I'm going to put a 2 on the outside to indicate that I have 2 nitrates that were used to make this compound neutral. So this is the formula for calcium and nitrate. Okay, let's look at another polyatomic, ammonium. When I look on my chart over here to find ammonium, I see ammonium's listed right here, and its charge is +1. It's NH4 +1. So I'm going to write that out. NH4, and its charge is +1. Nitrogen is just N, and its charge, because it's in group 15, its charge is -3, right? Because it steals 3 to get 8. So now I have to think, how many of these do I need? Well, 1 nitrogen will give me a -3 charge, and 1 ammonium will give me a +1. I obviously have more negatives than I do positives, so I need to add more positives. If I add another positive, NH4 ion, I'm still not at neutral. So I have to add 3 ammonium ions to get an even neutral compound, because these will add up to equal +3, and then this is going to be a -3, so my overall charge is neutral. So now I ask myself, how many NH4s did I use? Remember, NH4 has to be in parentheses because it's polyatomic. I had 1, 2, 3 NH4s, so I put a 3 here to indicate how many NH4s I used. I only have 1 nitrogen, so I don't need to put a number right here. I can leave this part right here blank because there's no number there. Okay, let's do another example. Strontium and phosphorus. Strontium symbol is SR, and phosphorus symbol is P. Strontium, SR, is in group 2, so its charge is +2. Phosphorus is in group 15, so its charge is -3. So right now, neither of these charges are even. So what do I need to add to get even? Well, right now, I have more negatives than I do have positives. So I'm going to add another positive. Okay, now my total charge is +4 and -3. And so I have more positives than I do negatives. So I'm going to add another negative. Is it even now? No, because this is a -6 charge and this is a +4 charge. If I add another +2, then I have +6 - 6, which equals 0. Something to keep in mind is that you can only add the charge of that element. So I can only ever add in increments of +2 because strontium has a +2 charge. I can only add increments of -3 because phosphorus is a -3 charge. So now that I have even, I have to think, how many strontiums did I have? I used 1, 2, 3, so I put a 3 next to strontium. How many phosphoruses did I use? 1, 2, so I put a 2 next to my phosphorus. Remember that subscript stands for the number of atoms used to make the compound neutral. Okay, let's do one more. Copper, 1, and carbonate. This is the most complicated problem you'll get. Copper is a transition metal. So if we look at copper on the periodic table, we do not know the charge of transition metals, right? Copper is in group 11, and we don't know the charge of 11. So what I do is I give you guys, whenever you're doing a transition metal, I will tell you what the charge is. The number of the Roman numeral number inside of the parentheses tells you what the charge of copper is, okay? So that 1, Roman numeral 1 inside the parentheses means +1. Transition metals will always be a positive charge because they're metals, and metals always have positive charges. They're always cations. So copper's charge is +1. Carbonate, we have to look on the periodic table of the polyatomics. So if I look here, we got to find carbonate. Here we go. Carbonate is CO3 with a -2 charge. So CO3, its charge is -2. So how many carbonates and how many coppers do I need to make a neutral compound? Well, carbonate's -2, copper's +1. So if I add another copper, I will get +2 and -2, which equals neutral. So let's see, how many coppers did I use? I used 2 coppers. So I write Cu and then a little 2 at the bottom to indicate I have 2 coppers. Carbonate is a polyatomic ion, and you always have to put polyatomic ions in parentheses. I only have 1 carbonate, so I don't put a number here. I could put 1, but we don't do that. Remember, 1 is pretty much assumed to be there, so I can just leave it blank. Sometimes, if you don't have a bunch of carbonates, then you don't even have to put the parentheses there. Hold on, wait a second. I just turned your world upside down. Stop buying the produce in the produce section for a second. So if I don't put the parentheses, that means that I only have 1 carbonate. The only reason you would put parentheses here is if you had more than 1 carbonate. That's when you would put the parentheses. Just as an FY to the I. And I can't erase it because life hates me right now. So that's the correct formula for copper carbonate. That is it for this video. We're going to move on to formula writing for covalent compounds. It's best to watch these 2 videos together so you know the difference between writing formulas for ionic and writing formulas for covalent.